Hi, friends. I'm Jamie Beard, and I lead a nonprofit called Project InnerSpace. And so we are all here to talk about climate change and what we're all going to do about it. And I think we can all agree that there is a whole lot of admiration of the problem in the climate space and not enough doing. We're all watching a lot of polar bear footage and doing a lot of hand-wringing. But we need concrete action, and we need to advance fast. And there's a huge opportunity for doing in the realm of clean energy, for massively scalable solutions, particularly in an area underrepresented currently in the global discourse about the future of clean energy. The massive, ubiquitous, and largely untapped clean energy source called geothermal energy. And I imagine what just popped into your heads when I said that is that time you spent in a hot spring on vacation. And most people do think of geothermal when they think of its surface manifestations, right? So geysers and hot springs and volcanoes. But the fact is that we are standing on a molten ball of energy that is as hot as the surface of our sun. But instead of 94 million miles away, it is right here beneath us, everywhere in the world. That means we could harness this massive clean energy source everywhere. Geothermal is everywhere. In some places, like Iceland, it's shallow, and we can even see it on the surface in features like geysers. I mean, the world is watching and waiting for Iceland's volcanoes to erupt right now, right? But in other places, it's deeper. But no matter where you are in the world, it is there, and it can be leveraged as a massive clean energy solution. So what will enable this? Well, for one, this is not a moonshot. By leveraging drilling and engineering innovations that have been advanced over the past decades, largely by the oil and gas industry, we can now engineer the subsurface to produce clean energy, heat, and even cooling. Anywhere in the world there's demand. And what's exciting here is that these core competencies, the ones needed to dramatically scale geothermal energy globally, are largely the same as the core competencies of the oil and gas industry. This means that with creative attention to developing business models, the right policy frameworks, and purposeful collaboration across currently polarized entities, think oil and gas industry and environmental groups, we can be poised for massive scale of geothermal energy by the end of this decade. And the impact of this shift of core competencies from oil and gas into geothermal on the future of energy and climate? Huge. Massive. If we develop geothermal energy at the same rate we currently drill for oil and gas globally, that's about 70,000 wells per year between 2030 and 2050. By 2050, we could meet 77% of global projected electricity demand and more than 100% of global projected heat demand with geothermal energy. And remember, geothermal is heat. And heat is one of our most difficult to decarbonize sectors. So let those numbers sink in for a moment. 77% electricity, 100% heat. Where did this come from? If you find these numbers surprising, you're not alone. Geothermal has languished in most penetration models in the single digits, so insignificant an estimate that is often grouped in the 1% or other category in the global energy mix for 2050. But that is the power of leveraging core competencies, the highly skilled and already trained workforce, and the existing global footprint of an energy industry that already exists. That's oil and gas. You've got workforce and technologies that can be a fast vehicle for geothermal growth. We can go fast. But there are obstacles. A few of them are significant enough to stand in the way of realizing the global potential of geothermal energy. And these obstacles are where Project InnerSpace is focused, on removing the major barriers that stand in the way of the exponential growth and development of geothermal energy by the end of this decade. So let's talk about one of the barriers to the exponential growth and development of geothermal that we're addressing: Geothermal holds massive potential, but there is no single resource, no global atlas that helps stakeholders understand where the low-hanging fruit is for the growth and development of geothermal in the world. Where are the places where geothermal should be pursued first? Where would have the highest impact and lowest cost? Where are the resources the shallowest? Where are they near demand centers? This amounts to a massive data project that would become a community asset, meaning all stakeholders would benefit from having such a tool. But no one entity is incentivized to commit the significant funding to develop such an asset and make it freely accessible. InnerSpace, in partnership with Google's Cloud and Earth Engine teams, has set out to develop such a tool, a map that will combine the InnerSpace R&D portfolio focused on the world's subsurface data with Google's surface data, coupled with a techno-economic model that will assist stakeholders in understanding how the subsurface and surface factors come together to impact geothermal project economics. Together, these data sets unite to produce a powerful tool to help the world understand the near and further term prospects of geothermal energy development globally. So today we announce GeoMap Beta, which we will launch in stages and with increasing functions and capabilities continent by continent in 2024 and 2025. This GeoMap Beta launch includes as its first case study the continent of Africa, to demonstrate the power this tool has to help accelerate the growth and development of geothermal energy, particularly in regions of the world that have a rapidly increasing need for clean energy as a result of growing economies and populations. This beta launch takes on, for deep dive analysis, as its first case study, Nigeria, with increasing data and layer availability as you zoom in to Lagos. So let's take a look at the tool. Here we see Africa from the lens of the tool. GeoMap combines dozens of surface and subsurface data layers, which all come together in a weighted analysis to indicate favorability of geothermal resources in particular regions. I'll note here that this map of the subsurface is a first of a kind in the world, combining the work of over 80 scientists globally, all working to quality assure and combine GeoMap's datasets in unique ways. This multi-layer approach creates some exciting outcomes in unexpected places, illuminating geothermal development potential in places prior mapping exercises have overlooked. Now zooming into Nigeria and Lagos with the tool, the GeoMap surface modules show surface elements like protected areas, transmission lines, energy demand estimates, leveraging machine learning models to estimate demand all the way down to the building level. In this screenshot of GeoMap, the colors on the buildings indicate estimated energy usage for each building, which is part of the machine learning module. Project InnerSpace prioritizes its mapping efforts on regions of the world that are projected to collectively contain more than 50% of the global population by 2050. We focus on locations where the world's future demand centers will be located. So in addition to our first case study of Nigeria, countries such as India, the United States, China, Indonesia, Pakistan, and Brazil are top candidates for near-term inclusion in GeoMap. Future iterations of GeoMap will increase both the number of data layers in already launched regions, as well as add new regions of the world for exploration and analysis. GeoMap Beta is freely accessible on the web at projectinnerspace.org. And we look forward to the rollout of the remainder of the world and to increasing the capabilities of GeoMap over the next 24 months. Friends, if we can get all hands on deck here, we can solve for both energy and climate. So on behalf of myself and the Project InnerSpace team, we look forward to engaging with the world to accelerate the growth and development of geothermal energy between now and the end of this decade. Let's get going.